Let's take a look at example 18 in chapter 17. For this example, we are told that H naught, the null hypothesis, is that mu equals 0.5, and that the alternative hypothesis is that mu is not equal to 0.5. So we know we have a two-sided test. So we'll be looking at both sides, the left and the right, for the critical region. The example here also gives us that mu naught is 0.5, sigma is 0.2887. The number of people, the number of numbers, is 100, and the x bar itself is 0.4365. So just collecting up the information, giving myself a little table. Testing a random number generator. A random number generator is supposed to produce random numbers that are uniformly distributed on an interval from 0 to 1. If this is true, the numbers generated come from a population with mu equal to 0.5 and sigma equal to 0.2887. That's mean of 0.5 and standard deviation 0.2887. A command to generate 100 random numbers gives outcome with mean x bar equals 0.4365. Assume that the population sigma remained fixed. We want to test the null hypothesis that mu equals 0.5 against the alternate hypothesis that mu does not equal 0.5. Calculate the value of the test statistic z. So the test statistic z is given to us as x bar minus mu naught divided by the standard deviation, which itself is divided by root n. For our problem, we have 0.4365 minus 0.5 divided by the quantity of 0.2887 divided by root 100. This yields a z-score of negative 2.20. So we'll go ahead and list that up here. We have a z-score of negative 2.20. Release the board a little. All right. We found the z-test statistic to be z equals negative 2.20. Use table C. Is z statistically significant at the 5% level, where alpha equals 0.05? All right, let's take a look at parts of the table C. In table C on page 701, you'll find a bottom row of Z star, you'll find a row for one-sided test, so one-sided P, and you'll find a row for the two-sided P. That's at the bottom of your table. You're also going to find and locate for this problem the 95% confidence interval, the 96%, these confidence intervals represent confidence levels, right? Okay, so we have at the top the alpha equals 5% corresponds to the 95% column. The alpha equals 1% corresponds to the 99% column. Okay, so in these columns, I'll fill it out for us a little. 1.96, 2.054, 2.326, 2.576. The first question, we can skip the one-sided info because we don't have one-sided, right? This is a two-sided test. I pointed at it and left it there as a reminder, right? So two-sided test. There's our little reminder. Okay, so these are the column table entries that we need. Now looking at question B, use table C, is Z statistically significant at the 5% level? We can either compare the Z values or the P values. For consistency, I'm going to compare the P values. So along with calculation of the Z test statistic for part A, then I will find in the book the information that I need so that I can have a P value where P is twice, so 2 times the the probability that we have a Z-score more extreme than negative 2.20 because that's our value. When we look this up, we get an area of 0.0139 from our table A. I got that from table A. When we multiply this times 2, we find that we have a p-score of 0.278. And now, what question A, well, that was to aid question A. What question B is asking us is Z statistically significant at the 5% level? At the 5% level of your test, then one thing we can ask ourselves is P less than alpha? And our answer is yes. So we reject the null hypothesis. But you can also look at the z-scores themselves and ask yourself, is our z-score more extreme than the z-score on the chart, right? So our z-score of negative 2.20 is more extreme in absolute value than the z-score 1.96, right? So we are more extreme than this z-score. So again, we're going to reject the null hypothesis. That therefore concluding that mu is probably not 0.5. And part C asks us the same question, only in regards to the 1% level and the 2.576. So is P less than 0.1? No, right? We have a p-value of 0.0278. That's greater than 0.01. So we do not reject the null hypothesis. And we do conclude that the mu is 0.5. So do not reject. All right. For part D, between which two normal critical value Z star in the bottom of row C does Z lie between? Between what two numbers does the p-value lie? Does the test give good evidence against the null hypothesis? So I do want to keep track of P. So up by my Z, I'm going to also write what P is. P is 0.0278. And now let me erase some of this stuff here. It's erasing slowly. Okay, so we left our chart up. The yellows were answering part B, and the red ones were answering part C. So 0.278 is less than 0.05. And on this one, we did reject the null. So in the first one, we concluded that mu probably is not 0.5, right? That was our conclusion. And in the part C, our conclusion was that mu is 0.5, right? And so what we're getting is that with a 5% level, we are statistically significant, but at a 1% level, we're not, right? And so part D asks us, between which two normal critical Z stars in the bottom row of table C does Z lie? Well, that's between the 2.054 and the 2.326, right? So our Z-score itself in magnitude, so we'll call Z here in magnitude. The test statistic has the negative, but this time we're just talking about the magnitude itself. 326, and not the direction. And now between what two p-value, between what two numbers does the p-value lie? So p is between 0.04 and 0.02. And then it asks us, does the test give good evidence against the null hypothesis? And the answer is something to the effect of, we have significant or significance at the alpha equals 0.02 level, because at that level, we have p less than alpha, right? But not at alpha equals 0.04 level. So just like above, we had a significant test at the 5% level, but not the 1% level.